We're gonna continue to solve our beautiful quadratic equations by factoring. This time we're seeing our leading coefficient not equal to 1, right? So we did do factoring. We did do these type of equations or these type of quadratic trinomials and factoring as expressions, as polynomials. Now we're gonna go ahead and see them as equations and solve for them, okay? So again, quadratic equation, we have two variables. Remember that we have an x and a y, with our beautiful x value having a highest degree of beautiful 2. Okay, so we have our standard form. We make our beautiful y equal to 0, and then we solve for it, right? We are now going to have a value here in the front, our leading coefficient, that is not going to be 1. So here's our first beautiful part. So let's go ahead and copy the first one. 2n minus 2 times 4n plus 1 equals to 0. So what if it's already factored for us and we have this result? Then how do we solve? Well, yesterday we said that in order for our result, our product to be equal to 0 when two items are multiplying each other, one of them has to be 0, right? We have to identify which one is which. Well, we have two of them that we can possibly have a 0 for. Therefore, we have to solve for both of them, right? So yesterday we said, hey, my result or my product is 0. That means that one of these beautiful factors has to equal to 0. So we're going to figure out what value makes this first factor equal to 0 and what value makes this second factor equal to 0. So let's go ahead and make our first factor, 3n minus 2 equal to 0. And the second factor, 4n plus 1 equal to 0. All right, so how do I solve? It's a two-step equation. What's my first inverse? Add 2, we're left with 3n equals 2. And then our last step, divide by 3. N equals 2 over beautiful 3. Can we have fractions as solutions? Yes, you can. All right, next one. Subtract 1, we're left with 4n equals -1. Next step, divide by beautiful 4, we're left with n equals 1 over 4. So my solutions here are two of them. They happen to be fractions. Yes, we can add fractions as solutions. Sorry, negative. Yes, there you go. It's there. It still is it. Check your work. All right. Not too bad, right? We're just getting started. Now let's go ahead and see if we have this example. Do we have two factors? We have m, and inside we have m minus 3. First things first, you will have the instinct to try to distribute, right? You don't need to. Now, what's happening here is, again, we have the statement that are product, meaning that whenever they multiply together, they equal what? 0. It means that one of these beautiful values has to equal 0. Let's go ahead and figure out what that value is. My first factor is a monomial, meaning that it only has one term. So therefore, that single term, we're going to make it equal to 0. My second factor is a binomial, meaning that it has two terms. We're going to make that beautiful binomial equal to 0. All right. The first one, guess what? It's already solved for us. The second one, all we have to do is our beautiful inverse operation. So we have to add 3. Therefore, m equals beautiful positive 3. So we have our two solutions, 0 and 3. Not too bad. Okay. Nice basket. This is too easy. Let's step it up. All right, so let's go ahead and continue. Let's see, we have this example. We have k squared equals -4k minus 4. So first things first, we always like to make one of the sides equal to 0. So we're gonna go ahead and find out what side. Well, again, you guys have a tool belt and you guys get to use your tools however you guys like. There's different ways on how to make one side equal to 0. You can go ahead and choose either the left side or the right side. Again, remember when we have an equation, both sides are the same, so you can go ahead and decide whether I remove k squared and switch it to the opposite side, or I remove negative 4k and negative 4 and move them to the other side. So it's your choice. What do you guys want to do? What do you guys want to do? So you guys want to move the k squared, so we only move one beautiful term. So if we do that, I'm going to go ahead and subtract k squared minus k squared. Now, be very careful, guys. On my beautiful right side, there's no other k squared term. So we cannot combine it with any other terms that is on the right side. We cannot combine it with negative 4k or 4 because they don't have the same degree. So this time, my left side is equal to 0. Can that be possible? Yes, we can. We're going to be left with negative k squared minus 4k minus 4. Now, what did we say that whenever we had a coefficient that was not equal to 1? Well, in this case, it happens to be what? Negative 1. So I'm going to factor it out. So I have 0 equals negative 1 k squared. We factor out the negative 1. Positive 4k. Negative 4, we factor it out. We have positive 4. What do we do to each side? Divide by 1, divide by 1. So therefore we have, let me go ahead and write it how we usually see it, k squared plus 4k plus 4 equals 0. Can I switch the terms? Yes, I can. As long as I'm not switching anything else, it's just basically grabbing the whole entire thing and just boop, just flipping it. Okay. Let's see. Factor. Two numbers that multiply to 4 and add up to 4. 2 and 2. So we have k, not x. K plus 2 and k plus 2 equals 0. Now, what do we see here? They have the same beautiful value. So because they have the same factor, we only have to write it down once. So therefore, we only have one solution. So Ms. Vasquez, we always had 2. There's a possibility for you guys to have 1, and I'll show you guys how that looks graphically. Let's continue. Ahora sí. Let's go and do this one. 3x to the power of 3 minus 6x equals 0. Okay. Our goal here is to factor. What method can we use to factor here? Yeah. GCF. A ver, what is that GCF? 3 and beautiful x. Take it out. Ahora sí, what are we left with inside? We're left with x minus 2 equals 0. Now, in the previous example, I told you guys you had m, and then you had, I think it was m minus 2 equals 0. 1 term and 2 terms. What do I do to those 2 factors? Make them equal each to 0. So 3x equals 0 and x minus 2 equals 0. So what times 3 is 0? Beautiful 0. So one of my solutions is 0. And we add 2 on the second one, and it happens to be beautiful positive No, que no. So if we have just a one term factor, we can still make it equal to 0. The other terms have, the other factors have 2 terms. Ahora sí, let's step it up. We're getting ready. We're getting there. Ahora sí, let's see what happens when we have our beautiful values here. We have 10n squared minus 35 equals 65n. Am I going too fast? Okay. All right, so what do we have to do? We have to make one side equal to 0. All right, so how do we do that? Well, only one term is given to us on the right side, so let's go ahead and move that one term. Subtract on one side, subtract it on the opposite side. Again, do not confuse your terms, okay? Some terms are not alike, and you have to make sure you guys identify which ones are not alike and which ones are. So we have 10n squared minus 65n. Let's go ahead and write it in standard form. Minus 35 equals 0. Why did we write the 0 on the left side? I mean, on the right side this time? Because it's just there. We can write it either or. However, we like to see it on the right side. Ahora sí. Let's see. Do we have, let's start with GCF. Do we have any GCFs? 5. So let's go ahead and take out that beautiful 5. 5. Do we have any n's? No, we don't have any variables, so it's just 5. So therefore we have 5n squared minus 65 times what is beautiful 5? 13, and what times 5 is 37, 35? Beautiful, negative 7 equals 0. What do we do with this beautiful GCF? Divide the entire beautiful equation by that beautiful value. We're left with 5n squared minus 13n minus 7 equals 0. Now, this is where it starts to get fun. Ms. Vasquez, we don't have that leading coefficient equal to 1. Do we know how to factor this? Yes, we said we can use beautiful Power Ranger method. So 2 numbers that multiply to negative 35 and add up to negative 13.
Wait.
Okay. Where's the 2? Oh, this is. Thank you, guys. Check your work. So this is 14. Negative 14 and add up to negative 13. Ahora sí, much more better. 14 and 1. So what do we do with those two values? We split that middle term, minus 14n plus beautiful n minus 7 equals beautiful 0. Then we what? Group. My beautiful GCF on my first group is 2n. We're left with n minus 7 plus beautiful 1, n minus 7 equals 0. N minus 7 is my first factor. The second factor is 2n plus beautiful 1. However, we're not done. We need to make each one of the equations what? Equal to 0. So we have 7n equals 0 and 2n plus 1 equals 0. Plus 7 plus 7. N equals positive 7 minus 1 minus 1. 2n equals negative 1, divide by 2, divide by 2. I'm left with n equals negative 1 over beautiful 2. I stop. No, can no. Go ahead. Oh, this is the reason why I was telling you guys that your factoring skills have to be to par. we're not going to stop seeing them now. They're gonna be in every single lesson. Well, almost every single lesson. They're gonna be a big part from what we're gonna be doing next, okay? Let's see. I want you guys to do one more on your own, and let's see if you guys got this. And I'll let you guys have your beautiful quizzes. See. Yeah, go ahead and try this one. Let's see if you guys got this one. 3x squared minus 8x equals 16. All on your own. And I'll pick people randomly. You guys got this. Subtracting it. So let's go ahead and subtract that beautiful value. Again, we want to make our beautiful side equal to 0. Now, in one of the examples, I did make the left side equal to 0 because it was just easier to move that one single term instead of moving the other terms on the other side. You guys can choose which side you guys want to make. Again, like I told you, you guys have a belt of tools and strategies. You guys can use however you guys need to use. However, you guys have to use them appropriately. Like, for example, you can't use a screwdriver to hammer something unless you guys don't have a hammer. But anyway, you guys have to use your tools appropriately, right? That's what I'm trying to say. So first things first, subtract 16, subtract 16. Do not combine any of the other terms with this beautiful constant. It's a not a like term. And I keep on emphasizing that beautiful statement. Honestly, how do I write my beautiful left side? 3x squared minus 8x minus 16x equals beautiful 0. All right. Can I factor this beautiful 3 or can I factor GCF out? No. So therefore, I have to do the Power Ranger method. So we have 3 times 16. Negative 48. And two values that add up to negative 8. So multiplies to negative 48 and adds up to negative 8. What are those two values? 12 and beautiful negative 4. If it's negative 4, it has to be negative 12 and positive 4. All right. So remember that those two values are going to split that middle term. So we have minus 12x and positive 4x. We bring down the other one, 16 and 3x squared. What do we do next? Group them equal to 0. What is my GCF on the first one? 3 and a x. And then we're left with x minus beautiful 4. On the second group, we have positive 4. And we're left with x minus 4 equals 0. What do we have in common? Let me go ahead and write these over here so you can see from the back. X minus 4 and there you go, 3x plus 4 equals 0. X minus 4 equals 0 and 3x plus 4 equals 0. Ahora sí, let's solve. This one's a one step. X equals positive 4. This is a two step. Minus 4, minus 4. 3x equals negative 4. Divide by 3, divide by 3. We're left with x equals negative 4 over beautiful 3. Not too bad. And again, once you guys get the hang of it and you practice, you'll get the hang of identifying these zeros by just looking at your beautiful factors. Okay, let me go ahead and give you guys your beautiful quizzes.